Alright guys, let's boot up TIS-100 again, and I'm going to show you the level 13 solve this time around. Love the booting sound of this system. Just reminds me of the good old days, hey? Alright, let's have a look. We're up to number 13. Here we go. Now, what's our task on number 13? Sequences are 0 terminated, read, reverse, and write to out. Alright, now this is a new system here. We've got a stack memory mode. What does that do? Now, a stack memory stack memory node. What it does, it lets you store several numbers in there. I had to consult the user manual so that I could understand how it works. But basically what happens is it's a storage. It's like a hard drive on your computer. You chuck a number in. For example, if you throw letter A in there, it gets stored. You chuck B in there, it gets stored on top of it. That's why it's called a stack. Letter C gets stored on top again. When you retrieve it, you can only retrieve the top one first, then the next, then the last one. Okay, so it has to be in order. So our task is to reverse a sequence of numbers. Okay, so what's the logic behind this? You chuck the numbers in one at a time, so 22, 84, 98, 43, 96. And then when you take from the storage, it will take it in the reverse order. So that's basically what we did. We threw numbers into the storage, and then we took them out one at a time, and chucked it through the output. Now, it's not as easy as that, because you've got to find the 0 so that you can terminate the storage. And so, for this one, I had to work out a way of the first module telling this last one to start grabbing, start with withdrawing the numbers, because I needed to get the first module to send a 0 down when it's a 0 instead of storing 0 into the system, so that we can start withdrawing. You can't just put a number in there, take it out, because you need to put all 5 or 6 numbers in before and send a 0 through this pipeline so that you can tell this module to start withdrawing, if that sort of makes sense. So let's go through what's happening. Alright, let's go through this storage module first. Number goes in, number gets stored, as well as goes into the memory. Okay, so number 22, it's in the memory now. Now, I chucked number 1 down. I put a counter, because if there are 5 units, you've got to tell this to take 5 numbers out. Otherwise, the computer jams up if you want to take 6 things out, but there's only 5 things in there. So I put a counter, which gets sent down into this storage, this little pipeline unit. All right, now J row 4 means go back to the top. Do it again. Next number is 84, so store it and move 1 down. Okay. You keep doing it. So now you can see that this module is a counter. I've chucked 2 1s down, so it becomes 2. I've processed 2 numbers so far. Okay, there's a 3rd number processed, so my counter's gone up to 3 now. Let's see what happens when we get to the 0. Okay, so all 5 of these numbers have gone through into the storage now. And we've got 5. The count is 5 now. Okay, now see what happens. When a 0 pops through, that means we've got to stop adding numbers into the storage. We've got to tell this guy to start withdrawing them and chucking them out. Okay, so a 0's gone through. I've detected that a 0's gone through. So now I move a 0 down instead of the number 1. Okay, so the 0 down here will tell this to start throwing things down. We go down to cut. So now the number 5, which is the total number of pieces of data in here, gets put through and sent across. We tell this machine that there are 5 pieces of data to withdraw. Okay, so now since the number is sent through, this guy starts working. He goes and puts 5 in here, and he checks that the number which is put through is not a 0. Because if it's a 0, then we want to ignore it. So, number 5, we move this number downwards. 96 goes down, subtract 1, 43 goes down, and we subtract 1 until it's back to 0. So when this hits 0, we know that there's no more data left. When it's 0, you've got to then tell this module that we're done with withdrawing. And this guy will tell this guy that we're done with withdrawing. Start sending data again. So this is a kind of nifty solve, because I've managed to send through a signal to communicate between the modules to tell them when to start and when to stop. So check this out. We'll let it run. You'll see that when this guy's moving, this guy stops moving. And when this guy's writing, then this guy stops moving until the signal is sent through. So there's a nice little, I guess, process happening, which is staged. And there we go. And you can see we read the numbers until it gets to 0. Then we spit out the numbers until it gets to 0 each time. Alright, so let's check out our solve. Average number of cycles. Yep. Used a few more than normal. I'm sure I can, streamline it a bit. But I'm glad that I managed to solve that one, because that was a fun one. Yeah, so I hope you enjoyed number 13 there. See you next time.